Hello friends, welcome to Study IQ. I am Naveen Kumar. Today let us discuss about binary number system. Nowadays the level of computer awareness questions which are being asked are not more of a computer awareness but they are more like a computer aptitude questions. That means these questions are more conceptual, okay, and require a little bit problem solving aptitude in order to crack these questions. So today let us understand a binary number system and how to convert from decimal number system to binary number system, and what is ones complement and twos complement, and let us do some practice questions. Okay, so let's get started. So what is binary number system? See, computers, they don't understand the multiple number systems. For example, what we use is called decimal number system. That means it contains 0 to 9, and any combination of higher numbers or bigger numbers have to be formed by combination of these numbers. Okay, but the computers, they won't understand all this. They use something known as logic gates. Okay, we shall learn about what is logic gate, what are logic gates, and all those things in the coming videos. But just know that they have something known as logic gates which understand only either 0 or 1. That means they are either on state or off state. Off means 0 and on means 1. So all the mathematical operations or any logical operations, they will only use binary number system. Okay, so the knowledge of binary number system is a must if you want to crack this computer exams. So comparison of decimal versus binary. See, decimal, it contains 10 symbols, and any higher number will be formed by combination of this. For example, after 9, 10, 11, and if we want to write 31, see, any number which is higher than this have to be formed by the combination of these numbers. Just like that, binary contains only two symbols, 0 or 1, and any higher number have to be formed by this combination only, just like the case with decimal. For example, higher number, like this is 0, 1, 2 will be 1, 0, 3 will be 1, 1, 4 will be 1, 0, 0. Okay, let us understand how this comes and all those things. Just know that any higher number has to be a combination of only these two. You can't find something like 1, 2 or any symbol other than 0 or 1 in binary number system. And the binary decimal number system is called as base 10 system because it contains 10 symbols to represent the numbers, and the binary number system is called as base 2 system. Okay. This decimal is easy for humans to use in day-to-day activities or day-to-day calculations, but this binary number system, as I said, it is only used by computers for storing data and also for doing mathematical or any logical operations. So this binary number system is the number system which is used by computers. Now let us understand. Okay, now that we understood that humans use decimal number system but computer uses what is called as binary, if you give the decimal number system, there has to be a mechanism, there has to be a way in which the computer converts this decimal number system into binary and uses it. So let us understand how this conversion is made. For example, if we have this decimal number system, in order to get the binary, we have to divide it by 2. We have to divide each number by 2, and we have to follow certain mechanism. We will see what is that mechanism. For example, 16. Okay, 16 is the decimal number system. If we want to convert it into binary, okay, so what we can do is we have to divide divide the number by 2. Okay, for example, 16 by 2 is 8, and at the each step we have to note down the remainder. Okay, so again we have to divide by 2. 8 by 2 is 4, and the remainder is 0. Now again we have to divide by 2, so 4 by 2 is 2 and the remainder is 0, and in the end 2 by 2 is 1 and the remainder is 0. We have to continue this process until we get the number, okay, this number which is less than 2. This is true for all the numbers. Okay, this is the step. I will repeat. You have to take the number and keep on dividing it by 2, and at the each step you have to note down the remainder. Okay, and this combination, okay, this reminders plus this quotient combination, this forms the binary number. Okay, So the number is 10000 to the base 2. In this binary number system, there is a concept called as LSB, that means least significant bit, and MSB, that is the most significant bit. Okay, so any digit which has higher value, okay, is called as most significant bit, and which has least value is called as least significant bit. Okay, so just remember this. This will be useful when we further discuss on other concepts in binary number system. So to start dividing with 2, so this will give 26 and the remainder is 0. Now again if we divide, we will get 13 and the remainder is 0. Now if we divide 13 by 2, we will get 6, but the remainder here is 1. Now again if we divide 6 by 2, we will get 3, because 6 by 2 is 3 and the remainder is 0. Now if we again divide 3 by 2, we will get 2 ones are 2 and the remainder is 1. And as we discussed, we have to take the numbers in this combination. That means the binary value of 52 is 1 1 0 1 0 0 to the base 2. Okay, and here this 1 is called as most significant bit again, and this 0 is called as least significant bit. And the order here is very important. That means we have to always take in this order. We can't say I'll take in this order. Okay, order will always be this, and this number, the final one, will always be the MSB, and this last one here is called as LSB. This is true always. Okay, so this is one way to do it. Let us discuss. There is another way. So the other way to do it is, we can take the numbers like this. Okay, just take one and at the each place, the next place, keep doubling that number. 16 and 32. Okay, we can just take till the maximum number that is available. Okay, here the maximum number which is available is 16. Okay, so we can substitute 16 as 1 0 0 0 0. That means this place value, okay, 16 plus 0 into 8, that means 0 into 4 plus 0 into 2 plus 0 into 1. So this value is 16. Instead of going through the division process, we can follow this procedure. Okay, let us take the example. Let us extend the example for 52. So take 1 and at the each step just double the number, 32 and 64. Here we have to take till 64 because this number, okay, when we wrote 32, we just saw that the existing number is more than 32. Okay, so we have to take till 64 and not more than this. Okay, so if we place 1 here, the number, okay, the number that we get will become more than 64. Okay, so this is not required. Okay, so what we can do is we can place from the next higher number. So this is 1, and if we place 32 plus 16, that will become 48. Okay, still we have to get 52. So we are just 4 away. Okay, we can substitute 0 to 8 and we just need 4. So we have to take 1 to this, and we need not do anything else because we already have 52 here. Okay, so the value here is 32 into 1 plus 16 into 1 plus 8 into 0 plus 4 into 1 plus 2 into 0 plus 1 into 0, which is equal to 52. Okay, and the binary number is this 110100 to the base 2. Okay, this concept will be more clear when we discuss binary to decimal conversion. Okay, so the actual method is we have to take the number and we have to divide it by 2, and at the each step we have to maintain the remainder. Okay, and the final result will be the combination as we discussed. But there is also another way to do it. Just take the number 1 and keep doubling it until you get the number which is given. Okay, here for example 16 is given, we don't need 32, and for the each place just position 1. Okay, so that we get the combination of the number which we are given. Okay, and this is the procedure that we have to follow. This concept will be clear when we discuss binary to decimal conversion. So let us discuss this binary to decimal conversion, that is from base 2 to base 10. In order to convert this is the procedure. That means we have to take the LSB first and we have to multiply it by 2 to the power of 0. Okay, this value will be increasing because in the first combination, in the first multiplication, the 2 to the power will be 0. In the next one, 2 to the power will be 1, and it will keep on increasing from step to step. For example, we have taken number 1011. Okay, so how we do is this one. Okay, this is in the increasing order of the power of 2. Okay, that means 1 into 2 to the power of 0 plus 1 into 2 to the power of 1 plus 0 into 2 to the power of 2 plus 1 into 2 to the power of 3. So 2 to the power of 0, any number to the power of 0 is 1. So we get 1 plus 2 to the power of 1 is 2 plus 0 into anything is 0 plus 2 cube is 8. So we have the number 11, which is to the base 10. Okay, this is the procedure. And at each step, if we see, this will be 2 to the power of 0 will be 1, 2 to the power of 1 will be 2, here 4, here 8. So at each step we are seeing the power, the number is increasing by the factor of powers of 2. Okay, that is the one reason why we use this conversion. That's why it works. So let us take the second example. As we discussed, the same number, what you have to do is, this is the least significant bit. You have to start with the multiple of powers of 2 to the power of 0 and 2 to the power of 1, so on, with the increasing order. So if we take this number 11101 to the base 2, this number with 2 to the power of 0 plus this will be having next significant value 0 into 2 to the power of 1, again 1 into 2 to the power of 2 plus again this 1 into 2 to the power of 3 plus this 1 into 2 to the power of 4, which is depicted here. Okay, and this 2 to the power of 0 is equal to 1, 0 into anything is 0 plus 2 square is 4, 2 cube is 8, 2 to the power of 4 is 16, and we have to add all this to get this 29. So this number converted into decimal is 29. Okay, now again this looks as 1, 2, 4, 8 and 16, and we have to take only till 16 because if we take the next double of this, it will be 32, and this 32 is greater than 29, so this was not required. Okay, that is the same concept which we are used in this. Now let us understand the concept known as ones complement. Nowadays in SBA exams, a question being asked like, find the ones complement of this, what is the ones complement of the number, like that. So what is this ones complement? This is very easy. Any number, okay, which is formed by converting ones to zeros and zeros to ones is called ones complement. It is that simple. That's it. For example, this number, okay, we have 1 1 0 1 1 0 0 1 1 0 0. Okay, if we are asked to find the ones complement of this, just convert ones into zeros and zeros into ones. So it will become 0 0 1 1 0 0 1 0 0 to the base 2. So ones complement of this number is this 1 0 0 1 1 0 0 1 1. The leading 0, it has no value, you can ignore it. So this is the ones complement of the given number. So in the same way, if you find the ones complement of this, 0 will become 1 1 0 0 1 1 0 0 1 0 1 0. This is the ones complement of this number. And in the same way for this, 0 0 0 0 1 1 1 1 0 to the base 2. Okay, so basically 1's complement means by the number which we get by converting the digits. If it is 0, we have to convert it into 1, and if it is 1, we have to convert it into 0. That's it. It is that simple. For example, 1's complement of this. Okay, this is 0 0 1 1 to the base 2. This is the 1's complement. And let us take another example, 1 1 1 0 0 0 1 to the base 2. So 1's complement of this is 0 1 1 1 and 0 0 0. Sometimes the option will be given as including 0 also or excluding 0. At MSB, okay, if there are zeros in MSB, we can ignore it. Just like 029 can be written as just 29 in decimal, and 02 can be written as just 2. Option can be given as 2 or 02. In the same way, the option might be given as 0 0 0 1 1 1 0 in this way for these kind of examples, or they might have omitted this. Okay, so we must be able to decide whether both are true, both are equal values. Okay, so we understood 1's complement. So now let's look at 2's complement. 2's complement is the concept which is most useful in also the while doing something known as subtraction. Okay, binary subtraction. So this is very important. How we get 2's complement? Any number, okay, find the 1's complement, okay, and add 1 to the result, then we will get the 2's complement. Okay, so I'll give you the background of binary addition. In binary addition, 1 plus 0 is equal to 1. Okay, just like in the decimal number system, 8 plus 0 is equal to 8, or any 5 plus 0 is equal to 5. Okay, but 1 plus 1 will become 0, but we'll get the carry 1. So 1 plus 1 will become 1 0. Just like when we add 8 plus 2, 8 plus 2 is 0, but we'll get the carry 1. So 8 plus 2 will become 10. Or suppose when we add 18 plus 19, okay, 8 plus 9 will become 17, but the carry will go to the next digit, so this will become 37. Just like this, here in the binary addition, 1 plus 1 is equal to 0, but it will give the carry 1. Okay, so just remember this concept in order to understand what is 2's complement. I mean, how to calculate 2's complement. Now let us look at an example. Okay, so the step is find the 1's complement, okay, and add 1 to it. So if we take this example, the number given is 101,001 to the base 2. So first step is we have to find 1's complement of it. How do you find 1's complement? Just convert 1's into zeros and zeros into 1's. So it will become 010,110 to the base 2. This is 1's complement. To this result, just add 1. That's it. 0 plus 1. So as we discussed, 0 plus 1 is equal to 1 and 1 plus 1 is equal to 0, but there is a carry 1. So here 0 plus 1 is 1, and so this is just like this, right? So 1 plus 0 is 1, 1 0 1 0 to the base 2. So 101 11 to the base 2 is the 2's complement of 101,001 to the base 2. Okay, now let us understand how to find the 2's complement of this. So apply the procedure, find the 1's complement of this number. So given number is 110011, it will become 001100, but we have to add 1 to it. So the answer will be 1011. Okay, so 101101 to the base 2 is the 2's complement of this number. Okay, so let us take another example with LSB becoming 1. 1000, okay, to the base 2. So we have to find the 2's complement of this number. So first step, convert it into 1's complement. What is 1's complement? 0111 to the base 2. Now we have to add 1 to it, which is the second step. So 1 plus 0 is 0, but 1 carry. Okay, so 1 plus 1 is 0, but 1 carry, and 1 plus 1 is 0 and 1 carry. So 1 plus 0 is 1 to the base 2. So 2's complement is find the ones complement of a number and add 1 to it. Okay, this has lots of application in computer. For example, finding, subtraction, and all those things. We shall look at that in a later section. So just know that to find the 2's complement, we have to find the 1's complement and just add 1 to it. Now let us look at simple examples for binary addition and binary subtraction. How addition is done and how subtraction is done. So as we discussed, in binary 1 plus 0 is equal to 1, 0 plus 0 is equal to 0, and 1 plus 1 will be 0 but 1 carry. Okay, so let us use this in this example. So 1 plus 0 is 1, and again 1 plus 0 is 1, 0 plus 1 is 1, 0 plus 1 is again 1, and 1 plus 0 is 1, but 1 plus 1 is 0 but 1 carry. Okay, this is the added value. Okay, in order to verify this, okay, we can convert it into decimal and verify, so that even we can verify and also we can recall whatever we discussed. Okay, so 1, 2, 4, 8, 16, how many digits are there? 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. If we substitute it, what we get? 1, 1, 0, 0, 1, 1. So the value is 48, because 32 plus 16 is 48. 48 plus 3 is 51. Okay, 51 we are adding with. So let us substitute this also here. 1, 0, 1, 1, 0, 0. So 32 plus this is 8, because 16 is 0, plus 4. Okay, how much is this? 32 plus 8 is 40. 40 plus 4 is 44. So if we add this, what we get? 5, 9. Okay, we get 95. So if we verify this, what do we get? 1, 2, 4, 8, 16, 32. How many digits you have here? 1, 2, 3, 4, 5, 6, 7. So we need 7 digits. 1, 2, 3, 4, 5, 6, 7. So next one is 64. So let us substitute here. 1, 0, 1, 1, 1, 1, 1, which is this one. Okay, so how much we are getting here? 64 plus 32 is 0, 16 plus 8 plus 4 plus 2 plus 1. So 64 plus 16 is 80, 88, 92 plus 2 is 94 plus 1 is 95. Okay, so which is this. So we verified this. Okay, so in order to add, this is the protocol that we follow. 1 plus 0 is 1, 0 plus 0 is 0, 1 plus 1 is 0 but 1 carry. Now let us look at the second example here. So it is important to note that 0 plus 0 is equal to 0, 1 plus 0 is equal to 0 plus 1 is equal to 1, and 1 plus 1 is equal to 0 with 1 carry. So if we apply this to here, 0 plus 0 is 0, 1 plus 1 is 0 but 1 carry. Again here 1 plus 1 is 0. Okay, 1 plus 1 is 0 but there is 1 carry, and 0 plus 1 is 1. Okay, and 1 plus 1 is 0 but 1 carry. 1 plus 1 is 0 and 1 carry, and 1 plus 1 is 0 plus 1 is 1, and this carry comes here. Okay, so we shall we'll understand this if we take another example. 1 plus 0 is 1, 0 plus 0 is 0, 1 plus 1 is 0 plus 1 carry. 1 plus 1 is 0 but 1 carry, and here we got 0, 0 plus 1 is 1. Again here 1 plus 1 is 0 but 1 carry, 1 plus 1 is 0 but 1 carry, 1 plus 1 is 0 and again 1 carry, 1 plus 1 is 0, 0 plus 1 is 1, but we got carry here, that will come here. Okay, this is the concept of binary addition. Okay, let us see subtraction. In order to subtract, we have to use what is called as 2's complement method. Okay, so what is that? That we have discussed, like 2's complement method can be used for subtraction. Okay, we'll see how it is used. In order to subtract it, what we have to do is, for example, if we want to subtract 9 from okay, sorry, we have to subtract 5 from 9. Okay, what we can do is we can calculate minus 5 and add 9 to it, so that will become the same thing, because plus into minus is equal to minus, and we'll get the same thing. Okay, so we are doing something like that. We are calculating negative of this number by using 2's complement method. So know that when you find the 2's complement of any binary number, you will get the negative number of it. That means if we have 5, okay, 5 binary number represented as, how do you represent 5? 0 1 0 1. Okay, if you find 2's complement of this number, we will get something called as minus 5. Okay, that is the value of that. So don't bother about how that is minus 5, that is computer dependent. You just know this as of now. Okay, so in order to subtract, what you have to do, you have to find the 2's complement of this number. So 2's complement of that number, second number, is 1 0 0 1 1 1 to the base 2 is there. So what we have to do, we have to first find the 1's complement of it. 1's complement is this, and we have to add 1 to it. So it will become 1 0 0 1 1 0. This is the 2's complement. So we have to add this 2's complement number to this minuend. So okay, what happens when we add this? So what is the minuend? 1 1 1 0 0 0 2 is the minuend. So the 2's complement what we found is 0 1 1 0 0 1. So we have to just add these numbers. Okay, so when we add this number, what do you get? 0 plus 1 is 1, 0 plus 0 is 0, 0 plus 0 again is 0, 1 plus 1 is 0 but 1 carry. So 1 plus 1 is 0, 0 plus 1 is 1 but 1 carry, and 1 plus 1 is 0 but 1 carry. Okay, this is the value. Okay, this is the value that we got by subtracting this. But one catch here is we have to ignore this final carry what we get. Okay, at the final carry what we get, we have to ignore it. That is the one thing but that we have to keep in our mind. Okay, so let us take another example. I'll leave this to you for practice. So we'll take this 1 1 0 0 0 0 to the base 2 minus 1 0 0 1 0 0 to the base 2. Okay, so what we have to do, we have to find 2's complement of this. 2's complement is 1's complement plus 1. So it will become 0 1 1 0 1 1, and we have to add 1 to it, which will become 1 plus 1 is 0, 1 carry, 1 plus 1 is 0, 1 carry, and here 1 1 1. Okay, this is the 2's complement of this number. So in order to subtract it, we have to add these two. Okay, first minuend and the 2's complement of the subtrahend. So it will become 1 1 0 0 0 0 to the base 2, and we have to add it with this 0 0 1 1 1. Okay, it will become 0 plus 0 0 0 1 1 1 plus 1 is 0 but 1 carry, 1 plus 1 is 0, and as I said 1 carry. This carry we have to ignore it. This is one logic in subtraction. Okay, this is the final value. Okay, so we are clear with binary addition and binary subtraction. So let us take one example for each, and let us understand, let us solve this. So in order to do this, the method what we told is 1 2 4 8 16 32 64 128. The next number is not needed because the next number will be more than 139. So this is sufficient. So 139 is 128 plus, if we add 64, that will become more than 190, which is not required. And if we add 32, that will become 160. This is also not required. And if we add 16, it will become 144, so which is also not required. But we need this. Okay, 128 plus 8 is 136. Okay, we don't need 4 because if we add 4, that will become 140. So 1 1. Okay, which will become 2 plus 1, which is 3, which is 139. Okay, the binary value of this is 1000 1011. Okay, the other method what we discussed, 139 dividing it by 2, which will become this will become 69, remainder is 1, and this is 34, remainder is 1, and 34 by 2 is 17. Okay, so remainder is 0. Okay, and here 17 is 2 8s are 16, which is, and remainder is 1, and here 2 4, remainder is 0, and here 2 2s are, remainder is 0, and here 2 1s are, remainder is 0. So which is 1 0 0 0 1 0 1 1, which both are same. Okay, so we discussed two methods of calculating this. This will be tedious, so in exam always use this method. Okay, so let us take another example for this one, converting this binary into the decimal. So how many numbers are there? 1 2 3 4 5 6 7 8. So we need 8 combinations: 1 2 4 8 16 32 64 128. 1 2 3 4 5 6 7. Okay, we have these 8 numbers. Just substitute this: 1 1 0 1 0 1 1 0. Okay, so the value will become 128 plus 64 plus 0 plus 16 plus 0 plus 4 plus 2 and 0. So if we add 12 18 22 24, so this will become 11, it will become 2. This is equal to 214 to the base 10. Okay, and we'll see ones complement and twos complement of these numbers. So ones complement will be just all the numbers inverted: 0 0 0 1 0 1 0 0 1 0 0. This is ones complement. If you add 1 to it, it will become twos complement. This is the same thing with this. So 1 0 1 0 1 0 1 1 1 1. Okay, so in order to find ones complement, we have to just negate it. All the ones will become 0 and all the zeros will become ones, and we have to add 1 to the final value, which will become 0 plus 1 is 1, 0 0 0 1 0 1 0 1 0. This is the twos complement of this value. Okay, so I hope you understood the concept. Now let us see the types of questions that can be asked in this. Okay, for example, which among the following is the binary conversion for this number 146? So 146, as we discussed, what we do is 1 2 4 8 16 32 64 128. The next number will be 256, which is not required because 146 is less than 256. So how do we get this binary value? 128 plus 64 will become more than 190, which is not required, and plus 32 will become more than it will become 160, plus 16, yes, because 128 plus 16 will be 144, and we need just 2. We don't need this much, we need just 2. Okay, so the answer is 1001 001 0. This is the correct answer. Okay, so you can use this method and you can easily find out the answer. So this is one kind of a question. So the next question is, if delta, okay, this is pronounced as delta, this triangle, if delta represents 1 and this O represents 0, what will be the ones complement of this number? Okay, in order to find it, we shall just convert it into ones and zeros. So delta is 1 and O is 0. So this is 0 1 1 0 0 1. Okay, because delta is 1 and O is 0. So ones complement in the sense all zeros should be ones and 1 should be 0. So this is equal to 1 0 0 1 1 0. Okay, so 1 0 0 1 1 0. This is the correct answer. Now let us look at another kind of question which are being asked recently. Here they say delta represents 1 and the circle represents 0. Okay, or the triangle, here they are mentioned as triangle only. This can be mentioned as delta or triangle if they are mentioned as triangle. So if triangle appears in the units place, so what is units place? For example, in 874, for example, this is units place, this is tens place, this is hundreds place. Okay, they are mentioning if the triangle appears in units place, then its value is 1. That means if the if the numbers that they are given is delta, okay, just the delta, nothing else, then its value is 1. If it appears in tens place, its value is double to 2. That means if it is appearing in this, okay, then its value is 2, that the number's value is 2. Okay, just like that it continues. Okay, they are saying this represents 0 and this represents 1, so in turn which is equal to 1 0, which is equal to 2. So we can clearly say they are giving example about, they are asking about binary number system. Okay, first decode this with the question. Okay, first we have to know that they are mentioning binary number system. We got to know about this from the question itself. Okay, this is the hint. So how will you represent 87 in this coded language? So they are clearly mentioning about the binary number system, and we know in order to convert, okay, this into binary, what we do is 1 2 4 8 16 32 64. We don't need 128 because 87 is less than 128. So the value is 1. If we add 32 to this, it will become more, not required. If we add 16, we definitely need this because it will become 80. 64 plus 16 is 80, and if we add this, this will become more than 87, not required. So these three. So the total answer is 87 now. But we have to convert that into whatever the logic that they said. This is this is represented by delta. 1 is represented by delta. So this is the answer. So delta 0 delta 0 triple delta. So this is the answer. B is the answer. Okay, so let us look at another question. What will be the code for this? So as we know, 0 0 0 1 0. If we follow the logic, double it, 8 16 32. How many is there? 1 2 3 4 5 6 7. So 1 2 4 8 16 32 and 64. 1 2 3 4 5 6 7. So substitute this. Delta is 1. So 1 1 0 0 0 1 0. What is the value? 64 plus 32 plus 0 plus 0 plus 0 plus 2. So 4 plus 2 is 6 plus 6 plus 2 is 8, and 6 plus 3 is 9. So 98 is the answer. And what will be the code for 1's complement of this? 1's complement. What is 1's complement? So this will become 0. Okay, they have given 1 1 0 1. By inverting, what we will get? 0 0 1 0. Okay, they are asking what is the code for this. So what is the code? 1 2 4 8. We have to substitute here. 0 0 1 0. The value is 2. Okay, so these are the types of questions which are being asked nowadays in all the bank exams. I hope you understood it. Thank you very much for watching.